Hi there. Now, before starting developing an actual IoT application, let's try to understand the details about the background networking involved in IoT. So let's begin. Now here, let's clear our understanding till now by looking at this simple block diagram. And it's very clear based upon this that what we are going to do is we are going to need a particular embedded processing unit, just like microcontroller or Raspberry Pi. Now, why do we need this particular embedded processing unit is to actually process the data coming from sensors, or if we have to turn on or off any actual physical device, then the same has to be done through this controller. This controller is also responsible to talk with this network interface and send this entire information or send this entire data right over to internet. Now, so far, in whatever discussions that we are going to have or whatever discussions that we are having, this controller for us here is Raspberry Pi. And we have seen number of different input sensors, as well as we have seen how we can make some output devices go on and off. All of this so far is done by some software which is written inside our Raspberry Pi, which is till now present in Python programming language. Now let's see what else do we need or what else do we need to have in order to create an IoT application. So these are the next steps. So right now the very first step is to connect our system to internet, then send the data over a communication channel, like so deciding a particular communication channel to connect to internet and send data. Then after having decided the communication channel, we have to understand what protocol we have to use in order to send data to our internet-based server. Once the data comes onto the server, next thing is to understand or next thing is to see how we can visualize the data and then perform some valuable analytics based upon our data. So let's see. Now, when it comes to connecting to the internet, there can be two options. One is a direct connection and another one is an indirect connection. Direct connection is something where you have a direct connectivity either in terms of LAN, Wi-Fi or cellular network. So in direct connection, what is happening? Your device or whatever your controller you have, let's call it D, is directly getting connected to internet through some mechanisms like LAN, Wi-Fi or cellular network. Indirect connection is a kind of connection where the controller or where the device that you are using is not having any capability to get directly connected with internet. In that case, what we have to do is we have to make use of some other communication protocols like Bluetooth, Zigbee or any other RF technology. So what happens is, if this is your sensor device or this is your end device, then it will communicate its data through some other technology to a host. It will also call it as gateway or host. This communication may happen through number of different communication channels. So this can be Zigbee, this can be RF, this can be Bluetooth. It can be number of different technologies available. And this gateway will then connect directly to the internet and send the data. So this is an indirect communication and this is a direct connection to internet, both of which are needed depending upon the application at hand. Now let's see what are the IoT communication requirements. Now you have to understand this thing very clearly that every IoT application has its own requirements. These connectivity applications which are working very good, very nice for one application, it may turn out that the same connectivity option is completely useless for some other kind of application. Now, in order to understand this thing very well, let's see what requirements our applications can have. For example, if I see about this first requirement, we can have thousands of remote sensors, to send the data onto the internet, and therefore the battery life is a critical consideration in many cases. So in many cases, your battery life is expected to run for several months or even for several years. So here the prime requirement is battery life. Then second time, there can be a case where we have a lot of heavy data like videos or images. In that case, high bandwidth is essential. In a third kind of requirement, what happens is whatever data that we are sending, it's very important. Let's consider banking information or your credit card or debit card information. In that case, your security is most essential rather than the battery life or high bandwidth. And then there can be some cases where there is a life or death decisions which are to be sent over internet, and therefore here the most important aspect is time. Not even security, not even bandwidth, and not even the battery life. Here the most important decisive factor is the time. Time that it takes for data to travel from device to internet and from device back to the from internet back to the device. Therefore, the time is most important criteria here. And remember, a single application will never have all of these requirements. It will have either one or two of these requirements whenever you are creating a particular application. In a nutshell, these are the communication requirements in IoT: low battery life, high bandwidth, security, and latency. Latency should be as low as possible. It means it should be very fast to send the data over internet and get the response back. Now, depending upon these communication requirements, you can choose the communication protocol as well as you can choose the server where you are going to send the data. Now, let's consider some applications in remote area. For example, there is a classic example which I had worked on, that was in jungle. So whenever you have to deploy an application in jungle, let's say for fire detection or let's say for a gunshot detection, in that case, direct internet connectivity is not possible, and therefore we need to route the data through some channels using communication like Zigbee or RF. So in that case, there is no direct connectivity, and here the connectivity from sensor is taken through some different protocols, and then a particular gateway will then transmit that data to internet. In our case, where we are using Raspberry Pi, our ultimate goal is to connect with internet, and with Raspberry Pi, we have these two options directly available with us, that is LAN as well as Wi-Fi. Now, depending upon which microcontroller you use, you have the option of using LAN, Wi-Fi or cellular connectivity to perform a direct connection. As said, Raspberry Pi already has these two interfaces. So with Raspberry Pi, we have Wi-Fi as well as LAN. Bluetooth is also there, and most important is LAN. Bluetooth is also there, but we use LAN or Wi-Fi because there is a direct connectivity with these things. With Bluetooth, what you can do is you can connect your Raspberry Pi with a phone which can act as a hotspot, and then it can connect to internet. So that is also an option. That is just an option which is present to us. If you are choosing some microcontrollers, or if you are not having Raspberry Pi in your application and if you have created your application on a microcontroller, then there is a possibility that the microcontroller that you are using may have an onboard Wi-Fi. Now, to give you an example here, ESP8266 as well as ESP32, these are some very popular microcontrollers which do have an on-chip Wi-Fi which can connect with your local Wi-Fi network. If you don't have Wi-Fi, just like Arduino Uno for example, Uno doesn't have any network interface. So in that case, you can use an external Wi-Fi module or Ethernet module or a cellular module. Cellular modules like SIM800 or SIM808 are a very nice way to give a direct connectivity to a microcontroller. Now, the connectivity has to be sorted. For us, with respect to Raspberry Pi, the connectivity is sorted for us. It is either LAN or Wi-Fi. The next thing to understand once getting connected to the network is how we are actually going to send the data over internet. There are a number of different communication protocols which are used in IoT. Most primarily, the most popular and the most common one are HTTP and HTTPS. But apart from HTTP and HTTPS, there are several other protocols also like COAP, that is Constrained Application Protocol, and AMQP and MQTT. AMQP is Advanced Message Queuing Protocol and MQTT is Message Queue Telemetry Transport. HTTP and HTTPS, although they are secure and they have a lot of different features, many a times they are not suitable for IoT. Because the number of data that we have to send, the latency that is expected, we need very fast communication, and sometimes HTTPS cannot correct onto that particular requirement. In such cases, what we have to do is we have to use specialized protocols for IoT like COAP or MQTT. If you have heard about IoT for some time, then you might know that MQTT is now considered to be a de facto standard for creating IoT applications. We'll see about all these protocols when we have to create an application onto it. For now, let's see what is and how we can use HTTP for creating an IoT application. Now, if you have to use HTTP to send data, then it has to be in some form of GET or POST requests, like xyz.com / my temperature is equal to something and something like that. So this is how data can flow through HTTP. And therefore, in order to test the communication using HTTP protocol, now we'll see some different cloud applications which support creating such an application. So let's see the cloud applications now, and let's try to create an actual IoT application with it. Then we will study in detail about MQTT and then try to understand how MQTT works and then get an application or create a project on MQTT as well. Thank you for watching this video.